Welcome. So in this video, we're going to be going through question 4 of exercise 18F. Let's give it a read and see what it says. It says, a particle moves in a straight line so that its position x centimeters relative to origin at time t seconds is given by x is this. So this is giving us the equation of its position. It says find its initial position, velocity, and acceleration, and hence describe its motion. Okie dokes. So what we're going to do here is, let me just quickly grab this. For question A, I need to find its initial position, velocity, and acceleration. So let's take the position first. So to find the initial position, all I'm going to do is say, well, when t is equal to 0, and I have x is equal to 4, 0 cubed minus 6, 0 squared plus 5, x is going to be equal to 5. Now, we can say what that means. What that means is that the initial position is 5 centimeters to the right of the origin. Perfect. Let's now go on to this one. So let's now go on to velocity. I'll do this one in a different color. Now we're going to talk about velocity. Velocity, remember, is v is equal to dx dt. So we differentiate x with respect to t, and it's going to be 12t squared minus 12t. I now am going to say, well, when t is equal to 0, what is it going to be? Well, I'm going to get v is equal to 12 0 squared minus 12 0. V will be equal to 0. Therefore, what I can say is that it is instantaneously, that might be repeating myself a bit, at rest. So it's not moving. So it's initially at rest at a position of 5 centimeters to the right of the origin. We've still got one more to go here. We now have to consider the acceleration. So let's grab another color. And now we're going to consider, oh, and I've actually got something written here. We'll come to this later because I have a feeling people might have some questions about all these things. Let's just put this down here for now. Next, we're going to talk about the acceleration. Now, remember that your acceleration is your change in velocity with respect to time. And what I'm going to do, well, what you have to do here is actually go dv dt. So you differentiate. What you're doing is you're differentiating your velocity. You're differentiating your velocity to find your acceleration. So what this one's going to be is 24t minus 12. Then I go t is equal to 0 to find what the acceleration is initially. So that's going to mean acceleration is going to be equal to 24 0 minus 12. The acceleration is going to be negative 12. And what we normally say, if you wanted to give this units, is you could say that it's centimeters a second squared. If you want to talk about it in terms of units. Now, what does that mean? What does it mean to have an acceleration of negative 12? Remember, your velocity tells you your acceleration tells you your change in velocity with respect to time. So what it means is it's starting to move to the left because it's got this negative sign. Starts moving to the left. So it is stationary, right? It is stationary. The velocity is 0, which means it's not moving. But the acceleration is telling me that it's going to start to move to the left. All right, let's now go on to B. Let me grab another color. Find the times when it's instantaneously at rest and determine its position and acceleration at those times. So what I'm going to do here is I'm using my velocity. So remember, your velocity is 12t squared minus 12t. I'm going to set that equal to 0, and it's going to be 12t squared minus 12t. Then, if I'm going to solve this, what I can do is I can take out 12t. That will leave me with t minus 1. Therefore, t is going to be equal to 0, right? Because when I set this equal to 0, it's just t equals 0. And I can set this equal to 0, which will mean t is equal to 1. So that means these are the two places in which I'm going to be at rest. And we already knew one of those. We already knew that I was going to be instantaneously at rest at v is equal to 0. And we know the corresponding acceleration to that. So I can write down that it's going to have an acceleration of negative 12 there, meaning it's going to begin moving to the left. Now, what is happening when t is equal to 1? Well, to figure this out, what I'm going to have to do is say my acceleration is, now what was it again? 24t minus 12, 24t minus 12. And then in the t spot, I'll put a 1, which means my acceleration is going to be 24 minus 12, which means it's going to be 12. So and that's right, isn't it? 24. I'm taking that and I'm putting it into when t equals 1. Yes. My acceleration will be 12. So what that means, what this is telling me, is that when t is greater than 1, it is moving to the right. Okay? The reason for that is because even though I'm stationary at t is equal to 1, and we know that because my velocity is 0 at that time, the fact that my acceleration here is a positive value tells me that I'm going to be, the velocity is going to be changing to positive and is going to be increasing from that point forward, which means it's going to be moving to the right. So that's what it means. It's going to be, my velocity will be positive, meaning it's going to be moving to the right. And sure enough, you can check this out. So for instance, I could take my velocity again, and let's just say, well, to test this out, what is, when t equals 2, what's my velocity? Well, my velocity would be 12, 2, 2 minus 1, and that's going to end up being, my velocity is going to be 24, 1 equals 24. So that means I'm moving 24 centimeters a second to the right. And that's what we knew beforehand when we figured out the acceleration, because that acceleration was telling me the change in velocity at that instantaneous moment at t equals 1. The ideas here, I agree, can sometimes be a bit tricky, and those of you who are doing physics are going to have a little bit of an advantage over everyone else in this topic, but hopefully that made sense in terms of what you're doing and in terms of what you had to find there. I will see you, I think that was it, wasn't it? Yes, I will see you in the next video.